Hi everybody, this is Liebert. I'm going to make some videos for you to try to help with the CT analyzer. This is the software from Bruker. And this version I'm using here is the 1.18.8. Just starting with an overview. Here you have, in this area here, you have the slices of your object. You can go through the slices by dragging this slider here. In this area here, you see a shadow projection that is created when you do the reconstruction of your sample in the N-Recon. And here you can go through the slices, each one of them. You can also use this area here to select a smaller region of interest. For example, if I want this one to be the top, I can right click and set top of selection. You see that this part here that is now in green, it means that it's not considered, it's not selected. And if I go down here, for example, and right click and set the bottom, now I have this region here as my region of interest. Another thing that I can do is go into the second tab. Here is the region of interest preview. This one will show me in red what is the region of interest, and now it is the whole image as the region of interest. If I want to reduce this region of interest, usually when I want to quantify my image, my object, I would like to have the region of interest to be correctly selected. And in this case here, I will make roughly a round shape and go for the round. And I can keep the object to be a little bit larger than the region of interest, just to make sure that everything inside the region of interest is going to be comprised of the object itself. I just swipe up and down to be sure that I am inside the object. In case it's not inside, you can also always create another region of interest in another region, and this is going to be extrapolated, as you can see, for example, here. In this case, it's going to extrapolate from a rectangle to a circle that was the one that we had before. So, and you can do it, for example, in different positions. It's going to extrapolate anyway from one to the other. But this is not the case here. I'm going to deselect this region of interest. I'm going to go all the way to the bottom and keep all my data set for the analysis. I want everything. Go all the way up. This is going to be my top. I just want to have a round shape to make sure that I have the image, not elliptic, but the round, to make sure that my image is comprised inside, or actually my region of interest is inside my image, so that I don't get any dark background to be quantified as pore. So here I'm on the top, I go all the way to the bottom, I make sure everything is inside. I can choose to save the region of interest. This option here is going to save a file that is going to be to keep the coordinates for my image, for my region of interest. And I can also choose to save a new data set, and this is a good option if you have a very large data set, because and if your region of interest is quite smaller than the data set itself, it's going to decrease a lot the amount of data that you have to work with. So going for this option here, you can choose to have another folder. You can browse here, or you can create a standard with a standard name that's called VOI or VOI. In this case, I have already done this, and I can just open this one here. As you have done this, you can go to the second tab, that is the region of interest, and make sure you load your region of interest. It needs to be loaded because otherwise you're going to quantify this black part here as void, as empty space, and this is not the case. Next one, the next tab is the binary selection. This one will help you selecting the threshold that is going to differentiate your object or your structure that is shown here in white from your background, or actually from the pores. So this is just a rough selection. I'm not going to select the proper now because I'm going to still apply some filters. And now I'm going to skip this one, the morphometry, and go to the custom processing. And in this one here, I have a lot of options that I can choose to work with. And I'm going to show you in detail some of them that we are going to use for preparing this sample to be analyzed and for the analysis itself. Now that I have selected my region of interest, my ROI is here. I have the whole dataset selected. I will go to the next tab, that is the binary selection. Here you can use this slider here to help you selecting the proper value of threshold that's going to separate, will segment your image from what is the structure itself and what is not the structure, the background or the voids or the empty space or the pores as you want. This selection here is just to help you because at first we can have an idea of the value we have to use, but most of the times we are going to use some filters before we apply the proper threshold. Here is just to have an idea. I have already worked with this, so I know that the value 66 is going to be the best one, but still you can see that there are some noises that are showing up as pores, empty space, the black spots here, and this is not desired. So I will show you how to work with this in the next tab. That's going to be our custom processing. That is the most important part of this software. This is a kind of plugin that is embedded here so that you can create your own task list that will help you work with the different processes. So I'm going to skip this one because this one is mostly not used for more robust analysis. So I'll go to this one. This one is going to load again the image in the memory. Sorry for this. And now we have here the custom processing, and I'm going to clean this task list. I don't need the task list now. And this tab here is going to give me the internal tab that is showing me all the options that I have here in the software. The first thing I'm going to do is to apply a filter. The filter here, if you double click here, you have a lot of options of filters. Make sure you have the last version of the CTAn. In the last ones they released some more filters here. So the one I'm going to use here, you can play around with these filters to see what is the best thing that can work for you. Play with the different options that you have inside each of the filters, and also play around with the iterations and the gradient, if you will. I'm going to use here this one, the way it is here. So if I just double click as I showed you, nothing happens. I have to run the plugin. So now I go to continue, and then it's going to apply the filtering. Some of the filters may take a while or a very long time. So if you are working with very large data sets, I would advise you to select a small region of interest, going from top to bottom, like very small but still representative, so that you can make it run faster. And of course, you can save this later and apply to the whole data set. So just for comparison here, I'm going to zoom in a bit here. I'm going to use the hand. And I will show you the original image and the filtered image. You see that the borders are preserved, so that's very important. That's why I used that filter. And I managed to remove these spots that are mostly noise, and now I got a smoother image. That's going to help me a lot in the selection of the threshold and when I apply the threshold. Okay, going back there, we can every time I apply something here in this internal tab that is going to be useful, or I'm sure I'm going to use in my task list, I can send it to this tab here, that is the task list tab. For doing it, you just go here, you mark, make sure you have everything set the way you want, and then you just click plus. This one is going to add to the task list. You can come here and check it is here. So the first thing is my filtering. The filtering is done, it's here. I'm going to apply now a threshold. I just click and unclick here, and it's going to fetch the data that is in this tab here, the binary selection. I know I have already selected 66, so this is just to run now. And this is the result. So it's always good to go through the image and check if there is no error or nothing that is very weird, or some problems that might have happened. And of course, you cannot have an idea if you don't compare to the original image. So it's always good to go in different regions, check for, like, this spot here might be if it may be noise or not. So comparing, actually this is a void, it exists. This one also exists, so it looks quite good. Of course, you can see here that the connection was not preserved. At least at some point it is preserved, but it comes to another region where it could not be preserved. But if I had chosen a different threshold, I would probably overestimate another part of my sample, and anyways, you have to lose somewhere, and then this is almost nothing for the quantification we want to have. So this is part of our error that we will have anyway. So this is working, it's okay. So I haven't put in the task list, so I will do it now. Now it's here. Next step here is to try to look for noises that might be undesirable in our image. And one thing I am sure that I don't like to have is any white spots that might be lost somewhere in my image. And as I know that my scaffold is a single scaffold that is all connected, I can use the despeckle. The despeckle has a lot of options here. It gives me many options, and I can choose to remove, for example, white speckles. But in this case, I know that sweep is going to be the best option here. If I use in the 3D space, I will remove all except the largest objects, the largest object, and I will make sure that I'm applying to the image. And when I run this one, I'm going to keep in my image just the structure that is connected to the biggest one. That is of course this one, and you can see that there is a spot here, but this spot is surely connected somehow in another region. So I'm just going, and you see it's connected here, and this lies just down. It's looks like it's loose, but it's not. It is connected here. So this is part of my structure. I cannot remove it. So I'm going to apply to the task list. And another thing I can do is to remove black spots or black speckles. And here I can choose to remove the black speckles. That would be noises that can be in the image somewhere, like in the middle of the white structure. If there are black spots or black speckles, they are going to be removed based on my choice here. So I want to remove those which volume are less than a certain amount of voxels. Voxels because I'm working in the 3D space. If I go for the 2D, it changes to pixels. And I want to apply to the image. And I select here the amount of voxels. You can choose yourself, but make sure that you have selected properly. I usually work with some mathematics to calculate the amount of pixels or voxels that might be not desired. And I usually count like 3 or 4 voxels per axis would be considered to be noise for me. So if I go for 3, I have 3 by 3 by 3, and I end up with 27. And then everything that is less than 27 voxels, every structure or black structure found here is going to be removed. I mean everything that is inside the white structure. And if I go for a 4 by 4 by 4, I end up with 64. That's my choice for now. I'm going to apply and wait. It might take some time. This one is not a big data set, so always make sure to swipe through the image and see if nothing happened that is not what you want. Make sure now to add to your task list, and then it's here. If you want to check, just double click. So now we have basically our image prepared for the first quantification. It's important to get familiar with these 4 buttons here. This one is the image view. That's the one you're looking at now. The image the way it is now. It was applied some of the processes here. You see now it is like this. This is the image, and this is the image inside the region of interest, image inside the ROI, and this is the ROI, and this is a clipboard. This is a space of memory that is kept for you to play with, to work with when you have sometimes you need to put some of your data set in another slot of memory so that you can work with this image view with another data set. Or if you look at this one here, the region of interest, this one must be exactly the region of interest you selected here. Of course, it can be changed based on processes that you can do here. And the region of interest, the image inside the region of interest, in this case here is going to be the same as the image because everything is inside this part here, this ROI. So this and this are the same for now. Just be familiarized with these buttons so that you are sure that you are looking at the proper or the right thing. If I go now for the 3D analysis and I choose for, if I double click here, I have the basic values that are these ones here, and some additional values that I can choose here. You can have your results as a text table or a single line or both of them. If you choose for both of them or a single text line, you have to select a file where you want your results to be saved. In this option here, in a single text line, every single text line will represent one data set or one result for you. If you have like many samples to analyze, you can choose this one and have the same file for all of them. So in the end, you will have a lot of different lines for different samples. It makes it much easier for you to analyze because you don't need to open file by file for each sample. So if I run this now, I'm going to quantify this structure that is exactly inside this volume. So I will go for this now, just for us to check. I'm going to include an additional value here, the thickness and the separation. And this gives me also an option to save a color-coded image. I can just save it to a subfolder so that we play with this later. I'm not going to add any other here. There is one here that will highlight if I choose for this number of objects. That is the porosity. I know that porosity is very important here. Is basically the one we want to look at, but at the same time we have this option here, the percent of object volume. This one is exactly representing my porosity. I can show you how, because exactly this is the amount of structure that we have inside the volume of interest. And if we make 100% minus this value, it gives me exactly the porosity. I will not then select porosity here because it takes much more time to quantify. And now I'll apply. It's calculating. So now it's finished. We can have the results here in the output file, and then I choose to open. It's going to use Excel. I have already selected Excel to be the one for opening the CSV files. So here you have the sequence of what you have done until you get to the analysis itself. And this is the 3D analysis. Here it starts. So what you see here as TV or total volume, it's the volume of interest that you selected in the first step. And everything that says object volume is the volume of the white structure or the structure that you selected in the threshold. And here is the object volume ratio to total volume. This is about 45%. This is the amount of structure that you have inside your selected volume. From here you can also quantify, calculate actually the porosity. And this is just in case here it's 100%. It's in case of it's already in percentage. So you make 100 minus this one here, and then it gives you the porosity of 55%. Another important one that we selected there, it was the structure thickness. So this is the average structure thickness of our material. This is 447 more or less micrometers, while the separation is about 892 micrometers. It's also important to be able to interpret these results, because here as the separation of the structures, it actually represents to me the average size of my pores, because the pores here are the space between the structures. So here I can also identify it as pore diameter, for example, and that would be this value here, the same value. Oops. The same value we have here. So these are the important parameters for us, at least for now. And here, just below the summary, you have the distribution of the structural thickness and also the distribution of the structural separation or the pore size. And this one is going to show you a range in between, like for example, this one is from the smallest pixel size until like 3 or 4 times in this case here it makes the distribution based on the amount of pores we have, or actually the range, the amount of range the software finds. And here you will see which percentage of the volume is within that range, and if you follow here, you see that it looks like a Gaussian curve. It goes up to close to where the mean value is, and then it drops again. So probably the average is around here, and actually it is 446. It's somewhere in here. Then it drops again. And here you also have the standard deviation. It's a good advice is to go through the documentation from Skyscan, from Bruker. They have a lot of method notes that you can go through so that you can understand every single analysis that can be done using this software. Going back here, I forgot to add the 3D analysis, and now I have a task list prepared for quantification of the structure or the pores. So I can just based on my interpretation, I can calculate, I can have the results for the structure, the thickness of the structure, and the thickness of the pores. That is actually the separation that is given to me, and some other parameters that can be quantified.